Welcome to Ask and Learn.
In this problem, we have a pulley at point B that's being pulled down with a force of 250 newtons. And we want to find the speed of the block in point A when it travels 1.5 meters. So we'll call that S, 1.5 meters. We want to find its speed, which we'll call V2. And we're also given the mass of the block, which is 10 kilograms. Well, right away we see a force and we see a distance. So we know that we're dealing with work here. And since we want to find the velocity, we know that there's a kinetic energy involved as well, since kinetic energy involves movement. So we can use the work energy principle, which is just the initial kinetic energy plus the work being done is equal to the final kinetic energy. Because this system is initially at rest, and the initial kinetic energy is zero because it's not moving, the velocity is zero. So then we just have the work being done is equal to the final kinetic energy, which is 1/2 mv2 squared. We'll call this equation 1. So let's look at the work being done. So work is just force times distance, but there are two forces involved. We have the force from point B that's pushing down, and we also have the force due to the weight of the block. The block is going to be pushing up by that force, but the weight is going to be pushing in the opposite direction. So our forces are the force due to the pulley minus the force due to the weight, which is just mass times gravity. And we multiply that times the distance it travels, which we've given as 1.5. Now we can just plug in our numbers. So force, we have 250 minus 10 for the mass times 9.8. And of course, all of this times 1.5. So for the work being done, we get 228. Let's plug this in to our equation. So we have on the left side, 228 is equal to 1/2 m, the mass of the block, 10 times v2 squared. And v2, the velocity, is what we're looking for. So let's just solve for v2. So v2 is equal to 228, and then 1/2 times 10 is 5. So divide both sides by 5. So you have 228 divided by 5, and then to get rid of the square, take the square root. So then the velocity, v2, is equal to 6.75 meters per second.